start out with a blank XNA game project. Windows game. I'm going to call this GNA Life Solution. And this is like a blank project. Alright. So this is how you code it up from scratch. So we'll start kind of from last week's thing. You know, we'll do the whole lot again. So the first thing you need some way to represent the game board. I'm not going to make any classes in this example here. It's going to be like the quickest possible solution, which was to get your 50 marks. This is what you'd have to have achieved, right? No classes, no objects, anything. Just we'll refactor it. We'll refactor it maybe in another class. We'll start making some classes to represent things. Well, the first thing you need to do is to store the game board. So that's a bool array. Oh yeah, and the next thing I want to do is I want to decide how many rows and how many columns I'm going to have. So I'm going to store those as well in variables. And again, there's loads of ways to solve this. This is like really just a hacked together solution, right? And you can refactor it, put things into classes to make it better OO, right? So let's just say the rows is equals to 100. And the number of columns is going to be equals to 100. And now I'm going to create my game board. Sorry, new bool. 100, 100. Alright. So now I've created my game board. And I know how many rows and columns I'm going to have. Next thing I'm going to do here is a method to clear the game board. So public void clear. And I pass in the game board as a parameter, a bool array. Like that. So rather than use the one, I'm actually going to pass it in as a parameter. And you'll see why I pass it in a parameter, because I'm going to keep two copies of the game board, the previous and the next one. So it makes sense to do a parameterized one. Alright, so what I want to do inside this is I want to go across an entire row, and then the next row, and then the next row, and the next row, and I'm going to set all the values in the array to be false. So what's that going to look like? Can anyone tell me? Nested for loop. Okay. So we'll go for row. Oops. Row equals 0, semicolon, row is less than the number of rows, semicolon, row plus plus. Alright, so that's going to go through all of the rows, and then we'll do another one here. For int col equals 0, semicolon, col is less than the number of columns. Alright, so what this actually means is, of course, you know, it's going to go an entire row, you know, column by column through the row, and then it will move on and do the next row, an entire column through the row. Alright, so that's my nested for loop. And what I need to do then is set the value at board, at position, row, and column to be equals to false. Alright, so that's me clearing the game board. So the next thing I'm going to do is draw the game board. So where's that code going to go? In the draw method. Alright. In order to draw the game board, I need to have a sprite to draw it with. So let's make a texture 2D, and I'm going to call this cell sprite. Alrighty. And I need to load that, don't I? Where do I put the loading code for the cell sprite? Into load content, right? So first of all, I need something to draw, so I'm going to add this to my solution first of all. So I'm going to add an existing item, and I save this on my desktop. So there's my desktop, and there's my white dot. Alright, so that's it in the project, and now I need to load it. So I'm going to put that code inside load content. Alright, so I called it cell sprite. Cell sprite equals content dot load texture 2D, and then I call it the white dot. Alright, Next thing I need to do is I need to go and draw that. So we'll come all the way down to the draw method. And the first thing you do in draw, can anyone tell me? Sprite batch.begin, alright? And then sprite batch.end. And you've gotten all of this code from any of my XNA examples. You'll see that any of the draw needs to be surrounded with a sprite batch.begin and sprite batch.end. So the next thing I want to do is do the same thing. I want to use my nested for loop to iterate through each cell. And if the cell is turned on, I'm going to draw it in black. If the cell is turned off, I'm going to draw it in white. Okay? And I need to calculate the X and Y position based on the cell, row and column. So I'll paste my nested for loop in there. And the one thing I definitely need to do here is I need to calculate the X and Y position where I need to draw the sprite. Now keep it in mind that it's row by row, column by column. So I'm just going to take the column multiplied by the width and the row multiplied by the height, and that's going to give me the position here. Does everybody understand that? Because if each cell we say is 5 by 5, so then I need to, this one's going to start at position 0, 0. This one's going to start at position over 0 and down 5. And this one's going to start at over 0 and down 10, and so on. So I use the width and the height to determine where to actually draw it. So, vector 2, pos equals new vector 2. And then pos dot x is going to be equals to the column multiplied by the cell sprite dot width. And then pos.y is going to be equals to the row multiplied by the cell sprite height. And then what I need to do is check to see if the game board at position row and column. So then I draw it in one color, else I'm going to draw it in another color. So that's my for loop. Or that's my if statement. Okay, so this is a Boolean array, so it's okay to do that because each cell is going to hold a value of either true or false. So you don't need to go equals true or equals false. It will just evaluate to either true or false. And if it's true, turn this off. If it's true, I want to draw it in black. Alright, so sprite batch dot draw. And then you see there's loads of different overloaded versions of this. This is the one that we're going to use. The first one takes the sprite cell, or the cell sprite I should say. Cell sprite, the next one is the position, and then the third one is what's called the tint. Color, we'll draw it in black if it's turned on, and we'll draw it in white if it's turned off. Alrighty, so that's my game board set up and my game board drawn. The next thing we want to do before we even, because you can run it now, but it isn't going to do a hell of a lot. You're just going to see a big white square on it. Okay, the next thing we want to do is randomly set some of those cells to be true so that we can get a pattern displayed. So where will I put that code? Initialize is a good place to put it, because initialize is meant to be where you set everything up, all right? And it only gets called once at the top of your program, so this is a good place to call that, all right? So there's loads of ways to do this. You can use the modulus operator. We're going to make use of the random in C#, the random object. So the one that I like to use here is just random.nextDouble, because random.nextDouble will return a value between 0 and 1. So if I want to say turn on 50% of the cells, I can just iterate through the whole 2D array, get this random value. If the random value is greater than a half, I turn the cell off. If it's less than a half, I turn the cell on, or something like that. So that's based on probabilities. There's loads of ways to do it. You could use the modulus operator. This is the way I chose to do it. So first thing we need to do is give this a datetime dot now dot milliseconds. Is that the one? Yeah. you have to initialize it. Again, if you look up random number in C#, this will tell you how you initialize the random number generated with a seed. The random number function uses something like the 10th decimal place of pi. So if you use this without passing in a seed, you'll get the same set of random numbers every time you run the program. So you initialize it with a random number seed, and then you get different random numbers, because they're not really random numbers, you know? They're what I call pseudo-random numbers. It uses some function to generate the random numbers. So you pass in a seed, and you'll get different sets of random numbers each time. So then we'll put in our nested for loop again. And I think I'll just copy and paste this. Where's my clear method? Now what I need to do is get the next value if for dot next next double, and say is greater than 0.5. I want to turn the cell on, so game board at position row column is equals to true. Otherwise, let's turn it off. Let's turn the cell off. Alright, so this code only gets executed once this initialized. Let's run it now and we should get a random game board. So there we go, here's a random game board. So it's turned 50% of them on and 50% of them are off. So well, let's just use Darren's little hack to put in the lines. So instead of using, 5 by 5, right, what we'll do is we'll leave a small gap between each cell, and that way the background will show through, the blue background will show through, and it will look like there's lines drawn. So, our white pixel cell is 5 pixels by 5, so instead of jumping over 5 pixels each time, we'll jump over 6 pixels each time. And then we'll see there'll be a small gap between each one. So instead of taking the cell width and the cell height, we can take the cell width and the cell height plus 1. No, hang on a sec. What are we doing wrong here?
Your backgrounds are black and white.
I think my background is blue, no? So I should see the blue. Should see the blue coming through. There we go. And then we've got a blue background, and you can see each of the cells like that. Alright, so we've just jumped over, instead of jumping 5 pixels each time, we jump over 6 pixels. And then that leaves you room, just for the background to show through. Is that alright with everybody? Okay, so now I've got my random game board. The next thing I need to do is implement the rules of life. And in order to do this, we're going to end up with a whole load of if statements. Alright, the first thing we need some way to calculate how many cells are alive around each cell on the board. So let's write a method to do that. Public int count alive, and I'm going to pass in the row and the column. Now, I'm going to end up with 8 if statements here, alright? And let's just consider how this needs to work here, right? So I'll rub this out a little bit. First thing is, let's imagine this is the cell that we're considering, okay? And I need to count how many cells are alive around this. So this is going to be represented by row and column. This is the row and the column we're currently talking about. This row here is equals to row minus 1, isn't it? Is everybody happy with that? This row here is equals to row plus 1, and then this is row. Isn't that right? So if I again have if I have column for this represents the current column. This is going to be the column plus 1, and this is going to be the column minus 1. Alright, so now I have a way to calculate the row and the column for each of the surrounding ones. And I'm going to end up with 8 if statements. This one, this one, this one, this one, this one, and these 3 here. So I end up with 8 if statements to check to see if the ones surrounding the current one are alive. And then for each one that I count as being equals to true, I add 1 to the count, because that means it's got an alive cell in it. Is that alright with everybody? You understand that? Alright, so I'm passing in the row and the column. first thing I'm going to do here is go int count equals to 0. There is one small, slightly complicated thing here. It's not really that complicated, and just that you have to consider the ones at the edge as well. Because if we're at the edge here, for example, there's nothing to the left. So if I basically take column -1 here, I'm going to end up with a value of -1, and I'm going to get an exception, an array index out of bounds exception in C#. So you need to also check to make sure that you're only checking, initially check to make sure if you're looking at this column, you only check the cells to the right, and if you're looking all the way to the right, you only check the cells to the left, and the same for the top and the bottom. So the first thing we need to do, let's do this one here. So in order to implement that if statement, it's going to be if, first of all, we need to check to make sure that there's a cell here. So we can go if the column is greater than 0 and the row is greater than 0. Alright, because if the column and row are at least 1, then that means there's a cell here that we need to check. Does that make sense? Alright. And board, call it game board, at position row -1, comma, column -1. Then we add 1 to the count. Alrighty, that's our first if statement. So we first of all check to make sure it's valid to check this one. If either of these returns false, if either of these evaluates the false, it won't bother checking the game board. It'll just say, no, that's it. It'll break out of the if statement before we get to that. Is that alright? So that's the first if statement. We've now checked this cell here. Does that make sense?
You can use a nested for loop.
You could. A nested for loop?
Go through all the 9 cells instead of 8. And then check if the middle one is alive.
Oh, that's a very clever solution.
It saves you right now like 8 mistakes.
It does, yeah. Let's do this way first, you're just using, a nested for loop, so you just go row by row, column by column. That's very good as well. But you also have to have the if statement to check to make sure.
I just didn't check the order. I just didn't
Oh,
show
very
the order.
good. Yeah, I know what you mean. Yeah, that would work as well. So there are several ways. This is the, if you like, the brute force way. Yeah, let's finish this one. Because I'd need to think about that one, right? But I bet you could refactor it, no problem. So then the next one we need to check here is this cell here. And this cell is going to be equals to the column -1. So we also need to check to make sure that there's a cell here to check, first of all. So you have to make sure your column is, your row is greater than 0. And game board at position row -1, comma, column. And that means there's a cell there, and so we go count ++. There's a cell there, and the cell is turned to true, so therefore we add 1 to our count. And then we'll do number 3. So this one is going to be if the row has to be greater than 0, yeah, and the column has to be less than the number of columns -1, and then we check the cell as well. Game board at position row, that's row -1, comma, column +1. Alrighty, so just think about this one for a sec. Now I'm checking this cell here, okay? So the first thing I need to check is to make sure that the row is greater than 0, because I can only check it for this one. I can't check here, because then I'm going to go -1 for the row. And then the next thing I'm going to check to see if the column, if there's, let's see how many cells here. 0, 1, 2, 3, 4, 5 is the count. The count is 6, but it goes from 0 up as far as 5. So I need to check to see if the column is 4 or less. Alright, if the column is 5, then that means I'm going to try and check 6. I'm going to go beyond the bounds of it. So that's the second part of the if statement. And if that's the case, then count ++. Alright, the next two. The next two are these two here, right? So this is going to be column This is column minus 1 on the same row. So if the column is greater than 0, don't need to check the row because I know that there's one at the row. And game board at position row and column minus 1. Count plus plus. And then we have the one to the right. So this is going to be if the column is less than the number of columns minus 1. And the game board at position row and column plus 1. Count plus plus. Alright. Everybody happy with that? So now I've checked these two here either side. Is everyone QAing my code? Make sure I'm doing it right. Good. Pay attention, right? Make sure I'm doing it right. If I make a mistake, we'll soon know about it because it either won't work or the program won't compile. Right, now we'll check the 3 on the bottom then, right? The 3 on the bottom, this is row plus 1 and column minus 1. Alright, so let's go. First of all, we have to check to see if the column is greater than 0 and the row has to be less than rows minus 1 and the cell, which is game board, at position, this is going to be row plus 1 comma column minus 1. So there's that one checked. So bracket, I go count plus plus. I've got 2 more. This one is going to be this one here is going to be the same column, but row plus 1, right? So you need to check to see if the row is less than the number of rows minus 1 and game board at position row plus 1 comma column. We go count plus plus and we just have 1 left. So this one here then is going to be the column plus 1 and the row plus 1. So we need to check to see if the column is less than the number of columns minus 1 and the row is less than the rows minus 1 and game board at position row plus 1 comma col plus 1 and we add 1 to the count. There we go. And then finally we return count. Alright, so now I have a method for checking a single cell and checking all the surrounding ones and counting the number of cells surrounding a line.
Very thorough count, yeah.
Oh sure, yeah, definitely. Alright, last thing we need to do is implement the game of life itself. And where's that going to go? In the update. Alright. So then what I need to do is, again, I'm going to copy and paste this bit. And this is going to be a few if statements as well. So the first thing I need to do is count the surrounding cells, count alive at position row comma col, And then I have two different if statements here. First of all, I check to see if the cell is already alive. If the cell is already alive, then there's three different possibilities, right? If game board at position row and col Alright, so what are the possibilities if the game board is alive, if the cell is alive? If the cell is alive, okay, and it has less than 2, if the count is less than 2, what happens? It dies. So we call this next game board at position row, comma col is equals to false. Alright? Any cell with less than 2 live neighbors dies, right? Any cell with 2 or 3 live neighbors survives, right? That's the next drill. If the count is equals to 2, or, count is equals to 3, it survives. Okay. Oops. And then the last rule is if it has greater than 3 cells, it dies due to overcrowding. Okay. Now, we need to have one additional rule, else. So the cell is dead, and if it has exactly 3 neighbors, then it comes to life. Alright, if the count is equals to 3, and the next game board at position row, comma col is equals to true. Alright, that's my game rules implemented. We're almost done. The last thing we have to do is just swap the game boards, right? And we have to remember to clear the next game board. So let's just do that first. Clear next game board. Alright. So now my next game board should be swapped. So I'm going to make a temporary one. Did everybody remember how to swap things in C? You have to make a temp, don't you? So we can go temp. Alright, so then what we do is, yeah, let's go game board, sorry, temp equals game board.
I just overwrite the game board now, you don't need anyone.
Yeah, but in order to do that, you have to swap them. How do you mean just overwrite it? Yeah, you could do. Just copy. You could copy the old game board or the next game board into game board. That would actually do just as well. Yeah, definitely. This saves you having to do that, though. You know. So temp equals game board. Game board equals next game board, and then next game board equals temp. We swap. We're done. 50 marks in your assignment for, we're still not even up at an hour yet, okay? So let's build it. I mean, I'll be very surprised if this just works straight off. I would imagine it's probably got some bugs in it, right? But so then that's your next thing, is to run it and see what bugs are in there. Might just work. Okay, so I've done a mistake here. So this one is checking to see if column is less than column is minus 1. So this is checking row minus 1 and column plus 1. Row minus 1 is this one, and column plus 1 is this one. So I also here, I forgot to check, I need to check to see if, yeah, the rows has to be greater than 0 as well. Okay, so I'll debug. Stop debugging that one, run it again. There you go. There's your assignment done in an hour. No need for tutorials. Alright, that's your 50 marks for the Game of Life assignment. No excuses. It's as easy as that, right? Let's take a few minutes of a break and we'll come back and we'll take a look at some of the masterpieces that some of the students in the class came up with. Alright?